By the end of this lesson, you should be able to use and evaluate indices. You should also be able to use positive, negative, and zero indices, and you should also be able to use the rules of indices. So let us look at uh, what indices are, or what index numbers are. So an index, an expression which is written in the form a to the power n is defined as the variable a raised to the power of n. So we say a is raised to the power of n. N is called the power or an index or an exponent of a. So an example, this one here is read as a to the power of 1, which is the same as a. If a is to the power of 2, so it means we multiply a 2 times, that is a times a. If a is raised to the power of 3, that is a times a times a 3 times. If a is to the power n, we multiply a n times. If we look at the rules which indices must satisfy, so some of the rules are here. Where n is a positive whole number, so a power n means we multiply a n times. For example, if 2 is raised to the power of 3, this means that we multiply 2 3 times, which will give 8 as the answer. Then if you look at the negative powers, any number to a negative power is the same as 1 out of that same number, but with a positive power, as you can see here. As you can see, a to the power of negative n is the same as 1 out of a to the power n. So if it is a to the power of negative 2, this is the same as 1 out of a to the power of positive 2. If it is 2 to the power of negative 1, it is the same as 1 out of 2 to the power of positive 1. 2 to the power of negative 2, 1 out of 2 to the power of positive 2, which is the same as 1 out of 2 times 2, which is 1 out of 4. Looking at other laws or rules, we have what we call the zero power. So any number which is not 0 and it is raised to the power of 0 is 1. For example, 8 to the power 0 is 1. So even if it was a number like 1,000, as long as this 1,000 is raised to the power of 0, the answer is always 1. So any number to the power of 0 is 1. So if you look at the fractional power, a to the power 1 out of n is the same as the nth root of a, So this means that if you have the power over half, that means that this is the same as the square root of a number. If you give a number a power of a third, this is the same as taking the cube root of that number. So an example is here, 9 to the power half is similar to the square root of 9, which is 3. Then 8 to the power third is the same as the cube root of 8, which is 2, as we can see there. So these are some of the other laws of indices. The first law is the multiplication law. So for it, it says whenever we are multiplying two indices with the same base, I mean the a here is the same, this a and a, but the powers are different. So we maintain the base but add the powers. That's why we have m plus n. So in this case here, an example is here when we are multiplying 2 power 2 times 2 power 3. We maintain the base, which is 2, but then add the powers such that here it is supposed to be 2. We maintain the base and then add the powers 2 plus 3. And this ends up giving us, because 2 plus 3 is 5, so it gives us this one here, which is the same as 32. So you do the same even if it is like this or like this, maintain the base and add the powers. So when we are dividing indices, that is the second law. What we do, since the base is the same, if the index numbers are of the same base, so what we do, we maintain the base and we subtract the power. So that's why the power m is subtracting the power n. So if the number is like this, the base is the same, we maintain that same base and we subtract the powers, which will be 3 minus 2. and the answer is 2 to the power 1, which is 2. So even if it is like this, we still do the same. So that is what we call the multiplication law and division law of indices, or what we call index numbers. Then another thing is that if m is equal to n, that is if the power, if you are dividing and then the powers, the power m is equal to n, that means that when you subtract this, you'll get 0. So that means that the answer will always be 1, because we said the number raised to the power of 0 is always equivalent to 1 when we are introducing. So if a number is like this one here, just because we said that a to the power negative n is the same as 1 out of the same number but with a positive power. So if you put it in this case, it will end up taking this a to the power negative n upwards, and then here you end up having a to the power m, because you're dividing, so you'll be dividing 1 out of a to the power of positive n. It's positive n. So meaning that here, if you want, you can just, because you're dividing, you can just take it as a to the power m divided by 1 out of this. Actually, you can even just subtract if you want, which is this step, subtract a negative power, or if you want, you can go ahead and multiply this, and then if you multiply this, then it means that you have to take the reciprocal of this, which is a to the power n, and you end up having, when you're multiplying, you add the powers, which is a power m plus n. So this is if you don't want to use this other way here, this is what you use. So the same applies to this if you're using the division law, or what we call the second law that we've looked at today. There is another rule here for indices, which is very important. If you have a number like this, raising it to a power, you maintain the base and then you multiply the powers, because this 2 is a power and these 3 are all powers. So we shall multiply the powers, which is the general rule shown here. So for example, here we multiply 3 with 2 to get 6. So the answer is 2 to the power 6, which is 64. Then if you are multiplying indices or index numbers which have the same powers, we can multiply their bases together, and then we keep the power the same, like this one here. So A has a power n and B has a power n. So the bases, we multiply the bases and we keep the power the same because they all have similar power. So even when we are dividing, like in this case here, we can factorize out the A and the B, and then we leave the power outside. So basically, those are the key rules that we look at when looking at index numbers. Remember to subscribe to our channel to enjoy all our lessons. Share, like, and comment on our lessons.